Hi, students. In this lecture, I am going to discuss problems from Irodov. Let us see first one. Let's see the question given. There are two stationary fields of force F bar equal to Ay I cap and F bar equal to Ax I cap plus By J cap, where I cap and J cap are unit vectors of the x and y axis and AB are constants. Find out whether these fields are potential. Okay, that means is a force conservative or not? Because we have learned that we define conservative force means we define potential or potential energy only for conservative fields. Okay, let us see how to decide. Right, first note down the given functions. First one F bar equal to F bar equal to Ay I cap, and second one F bar equal to Ax I cap plus By J cap. So now we have to decide these fields are, see what is given. Yes, whether these fields are potential or not. Okay. See the first one. So we are saying a force is a conservative if work done by that force is zero in a closed path, right? And from that we got a conclusion that work done is path independent. Let us see first one. If you take work done by this force, work done by that force, or let me take it as this is F1 and this is F2. Work done by that force, take it as F1. Integration of F bar dot ds bar. It is F bar dot ds bar. Now see calculation of that F bar Ay I cap dot ds bar dx I cap plus dy j cap. Okay. Now simplify this. I cap dot I cap, that is 1. I cap dot j cap 0. So focus only this first part. Integration of Ay dx. Okay. Now we can see if you want to simplify this, we should know relation between y and x. Okay. Without that, we cannot make this calculation. So we need the path equation. That means relation between x and y. That means this force is not conservative. So corresponding field is not potential. Okay. Right. Let us see the next one. W2 integral Ax I cap plus By J cap. This is F bar. F bar dot ds bar dx I cap plus dy j cap. Okay. Now simplify this. Ax, this will become Ax dx, right? Because I cap dot I cap, right? Next, By dy, because j cap dot j cap, right? Now you can see to simplify this. So what I can say here, ax dx, ax square by 2. This is by square by 2. So to make this calculation, we are not required any relation between x and y. That means the path equation is not required. That means this force is corresponding to potential field. That means this force is now conservative force. Like this, we can decide is a given force conservative or not. Okay, let us see next one. Right, see the question given. A body of mass m is pushed with the initial velocity v naught up an inclined plane set at an angle alpha to the horizon. The friction coefficient is equal to k. What distance will the body cover before it stops? And what work do the friction forces perform over this distance? Right? Initially velocity v naught, angle is alpha. Right? Let us see. Right now, right, first make a diagram. Inclined plane, inclined plane. That makes angle alpha. A body is now projected with a velocity v naught, and finally it comes to rest. Okay, so we have to find work done by frictional. Right, see what we can do here. It is asking before that, what distance will the body cover before it stops? How much distance it covers? See, while the body moving up, friction will be down. Okay, that means while moving up, we can say acceleration. So we have learned friction, acceleration while body is moving up the incline. That is equal to g into sine alpha plus mu cos alpha. Right. So either we can get it by using kinematics or by using a work energy theorem. Okay. So here I am using kinematics because it is more simple compared to that. Initial velocity v naught, finally zero. Displacement we want to calculate. A value is known, and this is downwards because mg sin alpha downwards, frictional force while body moving up, frictional force is downwards. So both are downwards, means net force is downwards. So acceleration is downwards. Okay. Then we can write v square minus u square equal to 2as v 0. So I'm writing s equal to, it is v naught square by 2a, and a value g into sine alpha plus mu cos alpha. Right. And once we have displacement, calculation of work done by frictional force, it is a very simple one. We can see here. Frictional force is a constant force. Since it is now slipping, friction is a kinetic, which is equal to mu k into normal reaction. Okay. So in fact, in the question it is given k. I have taken mu. Okay. So it is mu into normal reaction. Normal reaction is mg cos of frictional force. This is magnitude. Displacement, that is S, and S equal to V naught square upon 2g sine alpha plus mu cos. Between these two angle is 180 because displacement is up the incline, but frictional force is down the incline. So it is negatives. It is a very simple and direct one. Okay. Let us see next one. A small disk A slides down with initial velocity equal to 0 from the top of a smooth hill of height h, having a horizontal portion as shown. This body slides down, sliding. Okay, this is now horizontal part. What must be the height of the horizontal portion h to ensure the maximum distance is covered by the disk? What is it equal to? Okay, so we have to find the value of a small h. At the same time, what is the maximum value of s? Let us see. Right, first make the given diagram. There is one smooth surface. Not exactly okay, correct? Approximately. This is now surface. This is the horizontal part at a height small h. This is now small h. And this is a capital H. So we are releasing a body with a zero velocity from here. Now this slides, okay, and reaches now from here on ground at some distance. This is now yes, asking maximum value of yes, right? Now see what we can do here. First of all, when it comes from here to when it reaches now this point, first we have to focus its velocity how much, because now it becomes a horizontal projectile. Okay, then we have to focus what is the range. You can see initially height capital H, finally height small h. So loss in gravitational potential energy. Loss in gravitational potential energy converts into kinetic energy. Half mv square. M gets cancelled from this v value. Root of 2g into h minus h. Now, this is just like a horizontal projectile, right? And we have to calculate range. So range equal to, if you remember, range equal to velocity into time taken. Velocity. Velocity root 2g into h minus h. This is velocity. Velocity into time taken. In case of horizontal projectile, time taken to reach ground, it is equal to root of 2h by g, right? Now this value should be maximum. So this should be maximum means we have learned in maxima and minima. Whenever a quantity becomes maximum, minimum, or constant, its derivative must be zero. So differentiate that with respect to variable, that is small h, and make it equal to zero. Okay, let us see this value how much. G gets cancelled. 2, 2, so 4. I'm taking 2 outside. Remaining is now H into H minus H. The one which is inside the root, if that is maximum, then this total value also max. So differentiate now only the inner value, means inside the root. That implies d by dh of h minus h square equal to 0. Now see what we get. H minus 2h equal to 0. From that h equal to, sorry, small h equal to, I should write here small h is small h. So small h equal to h by, right? Now substitute this in this one. Then see what we get. H by 2. It becomes h by 2. That maximum value to root of h by 2. Again, h by 2 and 2 gets cancelled. It is equal to h. Okay. So it is simply basing on maxima and minima. That is one concept. Second, loss in gravitational potential energy converts into gain in the kinetic energy. And next one, it is horizontal projectile, right? Let us see next one. A small body A starts sliding from the height h down an inclined groove, passing into a half circle of radius h by 2 as shown. Assume the friction to be negligible. Find the velocity of the body at the highest point of its trajectory after breaking off the groove. Condition is after breaking off the groove. Its meaning is this body slides like this, follows now a path like this. Somewhere it will lose contact. The meaning of breaking off the groove, okay, losing contact. If you remember, while discussing vertical circular motion, I have discussed like when the body reaches certain position, string becomes loose. Then the only force acting on that particle is gravitational force. And it will be just like an oblique projectile. Means after that path will be parabolic. Okay. So if you are having those points in mind, and one more thing like when it loses contact, at what height losing contact, at that instant, what is velocity? At that instant, angle made by radius vector with upper vertical, if you have those points, then directly we can make calculation. So first let us see height is h. On reaching the bottom, see energy equation mgh. On reaching the bottom, this potential energy is lost completely, right? It is lost completely. This loss in potential energy converts into gain in the kinetic energy. See that? Right. It is now, it starts from a height h. It's a height from the bottom. That is given. That is given as h. So its loss in the gravitational potential energy converts into kinetic energy. Writing here law of conservation of mechanical energy. half mv square is equal to mgh, right? Now in this, say calculation, v value root 2ch. Okay. Now we are given this groove is having a radius of h by 2. Radius h by 2 means this I can write it as root of 4g h by 2, right? That means it is now root 4gr, right? In this form. So it is now less than root 5gr. So it is not able to complete the vertical circle, right? Now what I'm doing here, I'm using the result. Let us see once. I'm just using the concepts which I have discussed earlier while discussing a vertical circular motion. When string makes an angle theta with upper vertical, when string becomes loose, when string slacks, suppose this is now position where string slacks, angle is theta, velocity is v. So now in this, once a string slacks or once it loses a contact, it becomes now oblique projectile. Okay, that means you can see here velocity along the tangent. And this angle theta, that angle becomes now angle of projection. In case of oblique projectile, at a highest point, velocity equal to v cos theta. At a highest point, velocity equal to v cos theta, right? Now see what I'm doing here. Already we have learned how to find this theta, right? So we have learned cos theta equal to, okay, cos theta equal to u square minus 2gr upon 3gr. You can cross check once earlier lectures, discussion of vertical circular motion. In this case, u value at the bottom velocity, that is now root 4gr. 4gr minus 2gr, that is 2gr by 3gr. It is 2 by 3. So we got cos theta. And see v value. For v expression what we got? Square root of u square minus 2gr upon 3. So if you are not remembering this, we have to write once again force equation here. And again, we have to write energy equation and we have to solve those two. Okay. So from this, see what we get v value 4 minus 2, remaining 2, right? It is u square minus 2gr. U square value how much? 4gr. 4gr minus 2gr. That becomes how much? Root of 2gr upon 3. And we know r value. R value is h by 2. So it is now h by 2. H by 2. R equal to h by 2. That means 2r equal to h. So 2r equal to h. So root of gh by 3. Substitute that here. We get the answer. 2 by 3. That is a cos theta. V value root of gh by 3. That is our final answer. Okay. So you have to keep these points in mind. Cos theta and V. Okay. Let us see next one. A ball of mass m is suspended by a thread of length L with what minimum velocity has the point of suspension to be shifted in the horizontal direction for the ball to move along the circle about that point. What will be the tension of the thread at the moment it will be passing the horizontal position? In fact, question is very simple one. It's just matter of one step. Let us see carefully. So it is given that a ball of mass m is suspended. A ball of mass m is suspended from a string of length L. From a string of length L. And see with what minimum velocity has the point of suspension to be shifted in the horizontal direction. Now see carefully. If we provide a velocity root 5gn, if it is root 5gr, here r means cell, then this point is able to complete vertical circular motion. Okay. Now here what I am saying is, he is asking what velocity we have to provide for the point of suspension. So suppose for this point, velocity given is u left side. Okay, for this point, velocity u given left side. And for the ball, no velocity is given. Now solve the question with respect to the point of suspension. So with respect to that, its velocity will be 0 and velocity of the ball will be u. And if u value is root 5gn, it is able to complete vertical circle. That means u value must be equal to root 5gn. Okay, it is a very simple and direct one. Now he is asking what will be the tension when string becomes horizontal. Now see carefully. When it becomes horizontal, what is the tension? When string becomes horizontal, what is the tension? String horizontal means only tension provides centripetal force. See free body diagram. When string becomes horizontal, tension provides centripetal force. And mg will be along the tangent. Means mg becomes tangential force. That means T equal to mv square by r. R equal to L. Now, if we know V value, we can find tension. So to find the speed, I am using energy equation. So using law of conservation of mechanical energy. Let us take this bottom as reference level. Initially, no potential energy, only kinetic. That is a half mv square. That is a 5gm. That is it. Now potential energy will be mgh, h equal to L. String horizontal means this is at a height L, okay, mgl plus half mv square. So we want mv square, okay. See what we get. This is a 5 by 2, 5 by 2 minus 1, 3 by 2. 3 by 2 mgl, that is equal to half mv square, okay. So one is a force equation, other one is conservation of mechanical energy, right? Now 2 gets cancelled. Let us take directly mv square by L. Okay, I'm taking L here. From this, what we get mv square by L. That is equal to 3 mg. That is now tension. Okay. I hope you got clarity.